SBC has issued a level 2 out of 5 slight risk here for portions of the south for day 3 for severe thunderstorms. This is going to be parts of Mississippi, Louisiana, also some portions of Alabama and Tennessee, but notably Louisiana and Mississippi here with a marginal 1 out of 5 surrounding that. Looking at the discussion here, we do have all hazards at play. Um, they've mentioned convective mode being a little bit confusing. Not, I don't know about confusing, but just uncertain. They said uncertainty with convective mode, but wind shear is going to support a threat for tornadoes and some supercells. So I'm going to be looking at the synoptic pattern and what might be causing this. I will not really be looking at day 1 and day 2. While day 2 does seem a little bit intriguing and might have a slight uptick going into tomorrow, the main focus of this video is going to be on day 3 for this this risk here. And do keep in mind, day 3 there is some uncertainty, especially when it comes to storm mode, storm motion, storm speed, and intensity. So I'm going to use the name nest in what's one of our effective allowing models, one of those high resolution models, but again, we are a little bit out, so do take some of that with a grain of salt. The main thing we're going to be watching for is going to be this trough out here up in kind of off the coast of British Columbia. You can see right here, outlined right here, kind of this troughing feature. That is going to be our main area of attention as this continues to eject and deepen towards the south. This might, this is going to try to give on a little bit of a, trying to have a neutral tilt. We're going to look at the GFS here to see how this evolves with time. Do keep an eye on this here. Knowing how this kind of dips down, you have stronger flow surrounding the base of the trough on Thursday. That's going to be day 2. And generally also the pattern for Thursday, you can see that little shortwave trough out here for that region outlined in the day 2 could have some good characteristics, but moisture is unlikely to really return super strong. But if we look at our moisture out ahead of, for day 2, ahead of our approaching trough, let's check our dew point here. You can see moisture is returning to some regard at that time due to some surface cyclogenesis. But for the most part, you're not going to see a very strong cold front pushing out a lot of this moisture. So we are going to have this plume of moisture still advecting in from the Gulf as time goes on here. Again, if we go back here, you'll see you do have a lot of moist air advection on day 2 on Thursday, but then you don't have a strong advection out towards the Gulf due to any cold front. You're going to still have pretty rich moisture here setting up for the south in Louisiana and Mississippi here. And then we look back at 500 millibars here again. You have that trough that we saw earlier, deepening out here. Pretty cold core that will help for instability and just for healthiness of that trough. Upper level lows do want to have cold air associated with them. And then we'll watch this as this ejects. It does have a fairly positive tilt, but there are definitely some neutral tilt characteristics associated with it. The general troughing feature here is pretty, the axis is fairly positively tilted, which is not always the best for severe weather. But for the most part, this trough does have decent orientation. General southwest flow in the mid levels is going to help. In the upper levels, fairly strong jet stream associated with this trough. And you can see here a little better look at this trough, less of a positive tilt here, which would support severe weather if if this is to play out as the GFS says. Looking at 850 winds, this is often helpful for that supercell level. You can see even that cyclogenesis out here basically occurring and helping for that storms, for all that warm air advection and for that moisture. And again, as we saw, that moisture is present. The temperatures are pretty much go for thunderstorms, and had something here. Theta E. Instability, again, very much present here. Theta E is usually a pretty good measure of instability in the area, and you can see these deeper colors, meaning that higher levels of instability. Looking at Cape here, let's see how that's playing out. I seem to be lagging behind a little bit. Let's actually move to a closer model if possible. There we go. Took a little bit of a glitch there. Instability wise here, this is surface-based Cape right here. We are on this map. You can see definitely some stronger instability, again, more towards the south in Louisiana. That was mentioned in the SBC's discussion here, that hail might be more of the primary threat for this southwest area of the risk zone. And that definitely is the case here. You have more buoyancy due to the stronger instability. That could also lead to some stronger storms more towards the south. When it comes to tornadoes, something we want to look at is going to be hodographs. This is a hodograph map at 0 UTC, which can be this time right here. Basically, right as the sun is set about an hour prior to this. But the general conditions, you have a kind of trailing. I would I would call this a cold front. It's a little bit uncertain, might be kind of stalling out a little bit, but you do have this frontal boundary, likely leading to a more linear mode along it. And then you do again have this open warm sector out here, with a pretty good area actually of southerly flow. You can see Mississippi. This whole area here is pretty much due south, which can be good for any storms that are trying to form. They're gonna like that southerly flow. I'm looking at the hodographs here. The lines are going to be your storm motion vectors, but if you can see pretty strongly all the southerly flow still, and storms are going to like, again, it's going to like that southerly flow, especially if you have a storm motion out basically this direction. Helping with that good inflow is going to help build bigger storms. So the environment is lacking a little bit of instability, but does have a decent shear profile for any tornadoes that might want to occur. SIGTOR, again, you can see where the areas of kind of greatest tornado risk are. General environment seems to be decent out in Mississippi. I do question it in some regard when it comes to instability, because the stronger instability is going to be down south here in Louisiana, and that might be where we end up seeing better conditions for a good supercell. But Mississippi also could definitely support that, considering that shear profile looked better out there. They are closer, I believe, to some of the stronger winds. Well, winds do seem to be pretty uniform. Just trying to remember what we saw there. A lower level jet, let's check that as well. It does seem to be a little bit of an increase out here in Mississippi compared to Louisiana, but overall we do have a pretty stark environment for basically some mild severe weather. Not widespread. This is not some outbreak scenario, but you do have a enhanced environment for tornadoes. You have that linear mode of along the cold front, which could foster some strong winds, and even downdrafts from supercells could allow for some pretty strong winds and hail. So again, if you want to take anything out of this video, your hail risk can be probably located down here in Louisiana in that southwest area of the risk, and that's just where the stronger instability is. Basically anywhere in this slight risk, we'd probably see tornado possibilities. Again, probably going to be maximized just in the middle of the risk. Make that way too big. Maximized in the middle of this risk, somewhere along the southern Mississippi River here. And then let's lastly check our NAM nest model. This also, do keep in mind, this has a little bit of differences to the general NAM, which was a little bit different. Let's see, the RAP model here does get out a little further. This also could be an inhibitor to this setup. Looking at all this southwest flow, that's going to be a little more detrimental to any trying to develop supercells. So let's check this NAM nest model. Again, here, notice that winds are a little more southeasterly, which will add even more inflow and might be more beneficial for storms. You can see some firing there. Looks like this model has at 18Z, that's going to be basically right around noon. Doesn't really show a very strong cold frontal response, which is notable. Although even here you can see, and storms firing, definitely in that open warm sector. With all these little mini showers, that's kind of that warm air advection showers, but basically all that open warm sector storms, you do have an uncapped environment, and that is what the NAM nest is showing here. Here's actually a sounding I took earlier, and I wanted to save. This is at 20Z, this is going to be 2 p.m. Central. This is out in Louisiana, basically in the area of stronger instability there. And you can see right here, again, it's not super, what I like to call fat cape. You often see, and you want to see, if you want to see a storm, storms like to have fatter instability. So basically, you'd rather have temperature profile something like this. If you're going to compare, you want more instability in one area. That leads to stronger buoyancy and stronger updrafts. And in some regard, we do have that in the lower levels here. Pretty moist throughout the profile though, so kind of grungy, but noticing the 3 cape at 140, definitely lower level instability to be had. And this does look like a good setup for any trying to develop tornadic supercells. You have a very good profile in shear here, and southerly flow, shearing to more westerly. You see here in this photograph, or in this wind profile here, really exactly what you'd typically see for a supercell. Is it Is it a springtime Great Plains setup? No, not at all. But you do see that good shearing in the low levels there on the hydrograph. This would be supportive of severe convection. We do kind of question those lapse rates a little bit. The buoyancy is definitely a potential issue. The lapse rates are not super impressive. You don't have really quickly cooling aloft, which would support stronger updrafts and stronger storms because of that. But we don't really have that in this. Um, Again, if you look at the map here, this was taken out in that open warm sector, basically out here, where you are seeing all these little storms firing. So that's the environment you'd see. Again, most likely our main area of risk is going to be southern down here in Louisiana, but I wouldn't be surprised to see some more discrete cells out here in Mississippi, just due to less instability for the most part. Instability could be an issue. Instability could also be helpful. So it really depends on how our storm convective mode ends up going, just because it could get messy, and it is sometimes difficult to tell with that. That's not what I meant to click, but that's fine. So yeah, that's basically it for this video. Again, we are on day 3. There is some uncertainty. This might be worth a look back at maybe even day 1 when this does come. Again, but this is for Friday. That is going to be when this setup is for. So thank you for watching. Again, Happy New Year. I haven't had much chance to get content out due to classes. I'm winter break now, but I am preparing for the American Meteorology Conference in Houston. That's in about 2 weeks. So I have been preparing stuff for that. So I've been a little less on content because of that. But hopefully next semester I will be more active due to a severe weather forecasting class. So hopefully I will be able to make more content, which I really do enjoy. So thank you all for watching, and I will see you all next time.